Hey, everybody, and welcome to another episode of Adventures in Machine Learning. This week on our panel, we have Gant Laborde.
Hello, everybody.
I'm Charles Max Wood from devchat.tv, and this week we have a special guest, and that's Jorge Torres.
Hi, everybody. That's a good pronunciation there.
I lived in Italy for 2 years, so if I can roll my R's, I'm going to roll my R's. Are you a software engineer trying to learn machine learning? Then you should check out the course from educative.io called Machine Learning for Software Engineers. It has 87 lessons, 8 quizzes, 115 challenges, 163 playgrounds, and 2 code snippets. In other words, it's not just a set of videos that tell you how to do the thing. It actually walks you through all of the processes for machine learning. It gives you quizzes, it makes you do challenges, it's very hands-on. It's done with experts from companies like Google, Microsoft, Amazon, and Apple. And it is a terrific course that I've been learning to do machine learning. So go check it out at devchat.tv/learnml. That's devchat.tv/learnml. And that'll take you to the right place so you can sign up for the course. Do you want to introduce yourself real quick? Let people know who you are and why you're famous.
Well, I'm not famous. I hope this will be famous. Yeah. So the co-founder and CEO of MindsDB, and we are an open source framework for AutoML. So essentially, we realized that out of 100 developers, probably 90 don't really know how to implement well and deploy machine learning. And we wanted to provide an open source alternative to them. And that's what we do.
Awesome. I love open source, so I get excited about this stuff. So do you want to just give us kind of the 10,000-foot view on what MindsDB actually provides to people? And then we can dive into AutoML and some of the other cool stuff that you do.
Yeah. So essentially, the people that come to MindsDB, they come because they can create machine learning models with one line of code. Create, train, test, and essentially validate the model with a single line of code. And it supports a wide variety of data types. Like your data can have images, text, categorical variables, numerical, time series. And you can combine all of that and build close to state-of-the-art machine learning models without having to really have a PhD in machine learning to do so. And we essentially realized that a lot of companies that have data could be using machine learning, and developers are kind of like in between, like they have data science teams that have been carved out from normal development teams because their development life cycle is so much longer that and the skills that they require are different. But we think that data science will continue to merge back into normal development teams. And eventually, any machine learning task will be taken by any full stack engineer or even front engineer, whatever type of developer you are, you should be able to do a machine learning task. That's what we enable for them.
Nice. So I'm curious then, you make this easier. Is it much different from, say, going out and borrowing somebody else's model and then feeding it data?
Yeah, so that's one of the things that many of even the marketplaces that exist out there for machine learning models have failed, essentially because people have this kind of like negative tendency towards having to adjust their data to fit someone else's model. And on the other hand, a lot of people also, and rightly so, understand that the data that those models might have been trained on are not the same data that they have, and therefore these models probably will not give good predictions for this specific use case. And people have this tendency to believe that their data is inherently different from someone else's data. So what we understand, on the other hand, is if you break the problem on, like in our case, we only use label data, and that means you have to have a table. And if you break that table into the types of columns that you have, numerical, categorical, images, then what you can do is you can find what is the state-of-the-art way of building an embedding for each of the columns or each of the rows within each of the columns. And then you have to figure out what's the best way to combine all of these embeddings to get to an encoded target variable. And if you see machine learning like Lego blocks, then essentially you can break it down into 2 essential Lego blocks. The first one is autoencoders, which allow you to build embeddings. And the other one would be mixers, which allow you to mix the embeddings from that pre-processing stage all the way to the encoded state of the target variable. And then the problem, it's industry agnostic or even use case agnostic. It's more like data type constraints. And that enables a great amount of innovation, because a lot of the research that happens today is data type. So data type driven. So if you are a researcher, you're kind of like moving your kind of state of the art in text, on images. And essentially this allows us to borrow from like the research that is improving, and then enabling these capabilities to people that are not going to go and read a lot of papers around this or necessarily don't even care. And what is really important to happen there is that if you delegate the machine learning building blocks to third-party software like ours, then the important thing is that they can understand and trust that these models behave aligned with their intuitions. So the second part that MindsDB offers to people, even though when they initially arrive to MindsDB, they're just looking for an easy way to build machine learning, they clearly realize very sure after that they have to build explanations around why the model is predicting what it's predicting. And when it makes a prediction, can they trust that prediction or not? And as well as, making some really good insights about if the data that they provided is data that has potential biases or outliers that they should be aware of, because the models are only as good as the data they give them. So that essentially is what we kind of pack in one solution for them. Does that?
Well, I thought the explanation was it's machine learning, so it's magic. Right? No, I really like that. And I like that it connects the dots there. One thing that I'm also wondering, and I'll let Gant ask some questions in a minute, but I'm the mic hog here, and I'll admit it. So totally comfortable with it. I'm pretty new to machine learning, right? I've consumed some stuff. A lot of it is actually stuff that Gant made, but I'm still pretty new, right? I've kind of picked up some algorithm setups and then fed my data into them and things like that. And that's kind of why I asked the question in the first place. So since your approach is slightly different, is it easy to get started with? I mean, can I just download MindsDB and then say go, or are there other steps to it?
Yeah, so we wanted to reduce all the friction that we could possibly reduce and abstract as much complexity as we could. And after many iterations, right now, MindsDB, it's in the stage where it's the entry point to MindsDB is a Python library. So you do pip install MindsDB, and then so long you have a table, and you tell it from this table, I want to learn to predict these columns and use the rest as input. And then MindsDB will take it from there. And again, it's built on the assumption that developers have the capabilities to kind of like massage data and kind of pull all the data together to one single table. And with similar principles to the ones that scikit-learn had. The disadvantage of scikit-learn is that it cannot deal with more complex data types than categorical and numerical. And most of the times it's just numerical variables and categorical targets. So we wanted to kind of take that idea that scikit-learn had and simplify it a little bit more so that people don't think even of what model they're picking, but more of what they want to solve and what type of data is important to them. And then enable them to deal with a greater variety of data.
Now, you said developers would be managing the data. This is a little different from what I hear, at least from the bigger shops where they have like data engineers or data scientists. I mean, for some of these bigger applications, is that realistic? Or yeah, I guess I'm wondering about that approach too.
Yeah, that is a great intuition that you have. And from the years of experience that we've had building and implementing machine learning models, we realize one liability that we're also trying to cover here. Usually when you bring a data scientist, most companies make the mistake of bringing data scientists too early into a project. And in reality, data scientists, modern data scientists, like the guys that come from computer science, they get this dual responsibility delegated upon them that is dangerous one. The first one is they have to, of course, be very good at building models. But on the other hand, you delegate the responsibility of becoming very quickly a domain expert in the industry that you bring them. And there are many industries where this is very dangerous. Like in healthcare, I myself, I built predictive models for healthcare, and I have no medical background. Like I'm not a trained physician. And it's naive to like at the time when I was doing it was like 20-something kid to, build a predictive model for the outcome of patients. And really that is going to affect the care plan you're going to have when this person has no medical background. And still today, there are many systems that work like this. And on the other hand, you have like informed domain experts that have this, rightly so, high concern of this model is behaving in ways that they probably don't agree with. And really what our approach is, if we can enable domain experts to set requirements like they do for any software, and these requirements to be able to be tested very quick. Like the very first step of machine learning is, can I at least get an idea if this is going to work or not? Then it enables this workflow to be a little bit different, such that a domain expert sets a requirement, like, from this idea, I roughly want to predict from roughly this data, I want to predict this type of output, and let me know how it goes. And if that yields a good kind of like alignment with their intuitions, then the data scientist can come in and actually tweak the model for accuracy, which is what they're really good at. The data scientists and especially machine learning engineers, all of their training has been done around not specific domain expertise, like cross-dimensional domain expertise, but they've been trained to optimize a specific problem. And that's where we believe that is the right time to bring in the data scientist. And before that, it should be the domain expert that is driving the initiative for machine learning. And domain experts and developers have been working in a very kind of already well-refined process where domain experts set feature requirements and they get funneled through either product management or whoever manages that list. And then developers take those requirements and implement. And we developers were kind of builders rather than, people that are concerned about the specific implications of what those features mean. We can give our feedback, but ultimately we build. Our skill is to build stuff that has a requirement. And if we enable machine learning to go in that path, we're reducing a lot of liabilities on the one hand, and then we're enabling data scientists to jump in the right time. Does that give you a better picture?
Mm-hmm. Yeah. So I think that for everybody here, the concept of AutoML is very exciting. There's some just high level questions. So let's just start the top
what is
here.
AutoML?
Oh, let's go ahead, Jorge. Sorry, we actually didn't get that question. Go ahead.
Yeah, sorry, I'm a noob, so I'm asking a noob question.
No, that's a great question. So essentially, with AutoML, you want to automate a lot of the things that become repetitive when you're building machine learning models.
Okay.
And if you've done it multiple times, then you start to see those patterns. You start to see that you're always doing the same things, regardless of the problem. You end up doing very similar things. And the idea of AutoML initially was born to facilitate those steps that are repetitive. And the more you do it, then you start to realize that maybe for the very initial kind of approach, you don't even need a machine learning engineer involved. And I mean, we like in engineering and in general, there are so many use cases of things that used to be very complicated. And then someone abstracts that logic. And initially there's kind of like this friction from like the people that knew how to do those steps. Like to give you an example, big data, 12 years ago, you had to be a different type of engineer to do big data. You need to know MapReduce and parallel computing and a lot of things that will kind of allow you to have this title of big data engineer. And today, yes, there are still some, but most people can do big data with Spark, Ray, and they abstracted so much of that complexity that you're less and less thinking of the implications of what has been built behind because you simply trust that it works. And I think that we will get to the stage where most people will trust that AutoML works and it does the job that they need to get done. And then when they need to really optimize it, they can bring in kind of like a deep expert into that. It's just the same as you can start a cluster for today for big data without really knowing too much about it. And really, once you get into something that is working, then you can bring in someone that understands clustering and parallel computing to kind of like help you optimize it.
Right. So if I'm hearing you right, if I could boil it down to two sentences, essentially it's you can make a lot of assumptions about what most models need. And so you're going to make those assumptions, you're going to optimize for those cases, and then 70, 80, 90% of the cases can just start running. And then if you're in that other 10 to 30%, then you go out and you get some expert that's going to do something really custom.
Yeah.
All right, Gant, what were you asking? Sorry.
No, that's great. It's good. Like I want to make sure everybody who's listening, no matter how much experience they have or how little, or they just kind of like follow along. So if I throw out any words, if we start talking about something, that's perfect when you call us out on it, actually.
Gant is letting me be that guy. Thanks.
Well, I might be that guy here and there too, so don't worry about it. So I guess at the top level here, this library, is it built on top of any already well-known framework? I know you said you were on Python. Are you using PyTorch or TensorFlow underneath this?
Yeah, we support both PyTorch and TensorFlow. More and more, a lot of what we build today uses PyTorch. It's simpler to understand. And again, since we want to enable people to open up the box and they need to customize it.
Yeah.
It feels today that PyTorch is a little bit more intuitive, especially for recurrent types of data like time series and text. It feels like the building blocks of that are easier to build with PyTorch. But again, it's a flavor thing, and we support them both.
Oh, nice.
Most of what we do is on PyTorch.
Okay, so that's great. So if you're been spending a lot of time in PyTorch or even TensorFlow, then you can come along with Minds and sort of apply this on top in a certain degree. How often do you think a person has to peel away and actually go below there to go into PyTorch to adjust things? So for instance, let's say we were trying to train for something, and I guess let's start off with this. Is it perfect for classification problems? I know you were mentioning text. What's the limit? Is there, let's say, object detection? At what point does the spreadsheet start to break down, or is it actually, hey, it's perfect for this and this, don't use it for that? Well, in your opinion, where are the lines?
Yeah, and I think that your examples are on spot. So let me dive more into one of the ones that you gave.
Yeah.
Let's assume that you have some oncology data where you have images from radiology and you have some doctor notes. Those are two types of data. And then you have some biometrics of the patient, can be categorical and numerical. And again, in most real cases, your data involves multiple data types. And again, you can just throw this into MindsDB, and MindsDB will try to figure out the best way to mix all this data to predict if someone has cancer or not, or a specific type of cancer even. Let's make it a multi-class package. And ideally, you run this with MindsDB, and MindsDB kind of breaks it down into the different data types, so it understands that the images can process them with specific type of embedding, or it can get an embedding from those images from specific type of embedding methodology that we already have off the shelf. The doctor notes, it again goes and analyzes the length of the notes and tries to infer the language. And based on that, it will pick also a methodology to get the embeddings. And then for, say, the biometrics, it uses very standard one-hot encoding, or just turning the number into just a two-dimensional vector where you can also account for missing data. And it builds a model, it trains it, and you get some accuracy. Let's assume it's 70%. And initially, what this is telling you is, okay, this problem can be solved with the data that I have. And what MindsDB offers you out of the shelf is also of the data that you provided, which one is mostly taken into consideration. So let's assume that you have a whole bunch of biometrical data that it's meaningless for this prediction. It will at least tell you, how much is this contributing to this particular problem. And as you do sensitivity analysis, that means as you take the domain expert, say the oncologist, and the oncologist throws out there some of the use cases that they know what the output should, or at least where it should land, then MindsDB can also tell them what took into consideration to make that prediction. And let's assume that it's telling it that it's taking into consideration the image. And even though it took into consideration the image, the confidence that it has for that prediction is very low. And let's assume that they do this multiple times and they realize that essentially the image is very important to get to this prediction, but still they cannot get enough confidence from that image predicted. And what a data scientist can do at that time is go and see, okay, well, what is the embedding that you're taking from that image? And let's assume that we took just ResNet and we took a random layer from hidden layer from that architecture as the embedding. And then they can come and say, well, actually, I'm not going to use ResNet. I'm going to use something else because I know that for my type of data, this one is probably a better neural network. And then they can build one themselves. And if there is not already one for them available. So essentially what we enable in that scenario is the capacity for people to get started very quick. And then if they feel that they have a deeper expertise into building the embeddings for the specific data types, then they can go and adjust them. Text is another one where this is a very common example. The state of the art in text moves almost daily. And of course, we try to keep up. But I think that for a lot of the problems that we have today, we use BERT. And the idea is, of course, that if you have an embedding methodology that is better, you can just plug it in. And then you don't have to be concerned about the other data types that MindsDB is doing well. And essentially, that enables you to think of the problem on very specific issues that you want to solve, rather than taking this as a monolithic approach, which is what most of the times happens today. And then those monolithic approaches have two disadvantages. The first one is disadvantages. The first one is if you need to update something, it's essentially you have to rebuild a lot of building. And as technology, our understanding of machine learning evolves, then essentially you keep maintaining previous versions of your model and then newer versions of what you keep building. And you're essentially not really ever understanding what is it that you're optimizing, because you're just kind of doing this whack-a-mole of changing different parts of your model so you can kind of improve the accuracy, but you're not really certain of those. So we're trying to simplify that if you are an expert, but in essence, it only happens because you were able to test initially very quick if what your idea of something that could be predicted with machine learning was viable. Does that give you a better?
Yeah, absolutely. So let's see if we can bring people along. That's, so I have to say, wow, this is very deep, impressive, amazing. So the first thing that strikes me is that person could spend a lot of time learning, getting into machine learning and learning image classification. And then when they decide to go over to text, they have to essentially the logic has to be restructured again. You have to learn all these new concepts from what the advantage that, let's just say at a high level starting here, is that your process is already combining state-of-the-art, text classification with image classification by putting them into the spreadsheet. Now that by itself at the beginning of this, of like combining those, that's a difficult task, especially, for people who even have, masters in computer science and they've taken a lot of classes. So it sounds like y'all are way ahead of that. That's a great advantage immediately. You're kind of like cross combining those. And so you're not really limited. You have text input and you have image input and you're applying the state of the art. You're choosing, I guess, by default ResNet, or are you choosing a model and trying it out and then saying, okay, this one, and now let's try this model and try it out. So let's go back to the same oncologist example. Let's say you're using BERT for text. And then you've got this image here. And let's say it starts off with ResNet. Is it going to also like try Inception or other image classification models as well? Or is that where I have to open up the hatch and get in there with some wrenches and start trying some stuff out?
Yeah, that's a great question. So right now, off the shelf, it will pick one that it thinks is the best for the data, based, of course, on some rules that the system has built in. But then on the other hand, if you have a better intuition, then you can really just modify that part of text. So essentially, it's configuration based in the sense that you can generate the configuration automatically, or you can just take the configuration and put the building blocks that you want to put in there that are more aligned with your understanding of what will work better. And let's, for example, take into account some use cases that we find very recurrent is that you may have an image and you may have time series data that is sequential data about, let's go back to this very same example, about the visits that this person had into the doctor. And encoding time series data can be a tricky one because the time series can have also different data types. So say, for instance, that it's just readings from their heart, then that's fine. But likely is the case that you may have information that is sequential, but it's categories. Like in each visit, you have like a different diagnosis. And therefore, you want to also optimize these different building blocks of how is taken into account that time series data. So the idea that we want to facilitate for people is just start. And then once you start, then you can understand where MindsDB didn't get it that well in terms of defining the best way to encode data. And then we enable people to switch and swap those building blocks. But we also enable them to do it in a way that when they build a building block, it can be reused. So again, you may have a way to get embeddings from categorical data or even sequences of images. And if you build the encoder with the framework that we have, it allows you to reuse that not only for one specific data type, but let's assume that you have data types that involve sub-data types, then you can reuse this. And the way that we do it so as well is that when you're thinking of that encoder, you're only thinking of, again, just data types. And this allows you to clear your mind from the bigger problem and just tackle it one at a time. Does that also give you a little bit?
That's fantastic. So I guess I'll just kind of throw in another one. We're talking about cancer. In cancer, obviously, there's going to be, I don't know what a doctor would lean towards. But so Chuck, there's a difference of like where you can kind of have the error. I'm not sure if you're familiar with it. You could have like a type 1 error or a type 2 error. It's a little bit more of like false positives or false negatives. Right. Mm-hmm. And then in the essence of cancer, I don't know if the right thing is to have a lot more false positives so that the person gets more care, but you scare the hell out of them, or you get a lot more false negatives, which are like potentially life-threatening. So I guess false positives is where you'd want to lean.
Yeah, but some of the cancer treatments are also they're rather invasive.
They are, yeah.
And so I don't want to put anybody through that if they don't need it either.
Right. So let's say that Chuck and I are having some ethical conversation here about, whether we should have type 1 or type 2 and maybe a trade-off of them. Now, is there an opportunity for me, like if we're coming in here and we're back on this cancer detector, would it be something that I can set in that one line of code saying, all right, Chuck and I, we chatted this out. We want to have a lot of type 1 errors or something. We specifically want to do this one way or another.
Right.
Is that
They're on the side of type 1s, right? Is that what you're saying?
Yeah. Is it so fine-tuned that I can kind of dig in there? Or is that where you think you'll need to come back with the research and then go back into data science? I actually don't know how many knobs I get to twiddle with AutoML for each design, but that's excitingly interesting to me.
That is a great question. And so the answer is twofold.
Mm-hmm.
The first one is, in reality, the person that understands the implications of true positive and that type of sensitivity, we believe it's the domain expert. So as you clearly pointed out, the doctor is the one that understands where that lands. And the first approach that we take into this is we provide people a lot of metadata that is generated throughout the process of training, generating the model and whatnot, that can be explored like just by looking at this data. But we also provide them with a graphical user interface that they can kind of essentially upload any model that has been trained, and then they can visualize this type of information, like, okay, what is my confusion matrix? And we try to sway away from terms that are machine learning heavy, such as confusion matrix.
That's cool.
But in essence, it's a confusion matrix. And then they can visualize also this type of information. And we try to make it so that when they see it, they can hover around this confusion matrix and it will tell them, okay, what this is telling you is that, 80% of the times it tells you that you have cancer, you actually don't, and the other way around. And this in itself is just to provide a sense of, okay, when can you trust it, when you should trust it, and as well as this trade-off has been aligned with what you expect. Now, let's assume that it's not. Then we enable in this building blocks on the mixer part, like essentially when you mix all this data and retrain back, to define a loss function. And within that loss function, we use the default ones for like the specific data type that you want to predict, but you can change it and you can make it, biased. You can essentially build your own loss function for your problem. And we support a few out of the shelf, but you can change just that part. So if you think about it, then you're not even thinking now of how to encode images and text. And if your problem is really just that part, you just have to change a loss function, which is much simpler even than building the other building blocks. And again, the pattern that we see over and over, as your intuition tells you, is that usually when you have a machine learning problem, a lot of the stuff that you need is already built up there. You just have to spend a lot of time mixing all this data together. You build this dinosaur. And then you're going to spend a lot of time just kind of putting all this stuff together when you really wanted to focus on one single part, which in this case is, how do you optimize for that balance? And we want to enable and, of course, empower people that may have a little bit more in-depth knowledge to do so. But even if you don't have it, at least to make the domain expert aware of that, the implications of that trade-off of factors.
That's awesome. It's fantastic. Yeah.
Yeah, that makes sense. I also just want to call back to, I love the idea of having the domain expert actually make that call, right? Because neither Gant nor I are experts in cancer. And so I see the scary implications on one side and on the other, but I don't have a fine-tuned understanding to know which would actually be worse on somebody.
I'm sure there's an ethics board that almost, that has really, that's part of an education. I'm sure none of us know. Well, maybe Jorge, you do know, but I don't actually know where that is. But I'm really glad it's not up to us, Chuck. That's we would choose the wrong one. The coin would land on its side, I'm sure.
I agree.
And to be perfectly honest, a lot of these calls, we're having the same conversation in some ways about like COVID-19, right? And, do we open up the economy and what's that going to cost people versus, should we stay closed or stay closed to a certain degree? And, a lot of people seem to be on the extremes, and the extremes make me extremely uncomfortable because there are going to be unfortunate trade-offs both ways.
Oh, yeah.
And so I have my opinion, but my opinion isn't a very comfortable one, if that makes sense.
Well, I think you should just take both extremes and do them at the same time.
Oh, there we go.
Wear a gas mask in a bubble out in public closer to 6 feet than someone.
Right.
But that way, no one likes you.
Yeah. But it's interesting at the same time, the ethical conversations. That's probably another episode we should do, is how do you make the ethical decisions on, and how do you weigh that out? But anyway, I kind of took us on a tangent, but it's an interesting thought.
No, I think it's a beautiful
exercise
tangent,
for me.
And, I don't think that they're disjointed. I believe that actually we can even dive into the science fiction part of this, which is this idea of kind of machine learning and AI kind of becoming these tools that will decide for us, and they will overpower our capabilities, cognitive capabilities. And in reality, the only way that we can prevent that from happening is if we essentially build the systems to augment our decision-making capabilities. And the best way to do this is to make informed decisions rather than intuitions. And again, everyone today in this era of misinformation, they just have built a lot of intuitions about something, and that's how they decide to these extremes or wherever you land. And ideally, you would like to be in a world where people are just kind of taking as much information as possible and then make those decisions themselves as like they're domain experts of their lives. And I think that we're far away from enabling that to happen, but it only can happen if these tools like machine learning and whatnot, they are more and more enabled to the great majority of people. And that's essentially where we kind of land. We want to ensure that we can follow that path of democratizing, if you may, these tools, so that people have an easier way to make informed decisions, just because we're limited by our capacity to analyze every single type of data that exists out there. Like, if you're from the right, there's no way that you're going to be able to read everything from the left, even if you want to have like a non-biased approach. And computers, on the other hand, have this capacity to take in and ingest so much data and then just kind of funnel through insights that may be important for us to make those decisions.
Yeah. And I love the idea of democratizing it to the point where it's like, okay, well, we made this decision based off this data, and here's what we did, right? It's kind of like science. We argue about what science has been, settled. I hate the term, just in the sense that I love the idea of exploring even the things that we think we know and finding the holes in them. But, then it's, okay, well, this is how we settled it, right? Here's all the data we fed in. This is the model or algorithm or approach that we took. And I can go set it up and I can see what you saw, right? I don't have to just take your word for it. And I love that idea around machine learning. And I don't know how realistic that is, because I don't know if a lot of people are really going to want to know at that level. But the fact that it's out there and somebody that I trust can go do it, maybe that gets a little closer to home. I don't know. But I really dig that idea.
Yeah. Well, then I'm going to start off with a different set of random numbers and come up with a different conclusion.
Yeah, exactly. Yeah, but if you get a different conclusion, then it's like, what's the difference, right?
Right.
What did you do different from me? But
this is such a cool aspect, by the way. So, and this AutoML, what I really love is it's the next level of abstraction, and the processes you've explained today it's such a huge jump. Even people who've been studying for years and years and years about how to implement each of these different pieces of technology, gluing them all together is significantly complex. And did you say, so you're using autoencoders to create like a latent space? And is that bringing the information together? You're able to combine it there. That's something I've never even heard of. I'm sure it's probably a paper I could read about, but the way you're kind of taking these individual disciplines and gluing them together, can you elaborate for a second on that whole process? Because it's easy to go out and take a course on how to do one of these things, but how to take them all and make them mix together properly, that seems like its own science.
It is in fact. And so initially when we started with MindsDB, it was essentially a monolithic mistake where
I'm quoting you on that. That's going on the quote card.
Yeah.
And we learned from that it had to be broken down, as you said, into like the latent states of each of the columns that you had. And then breaking that problem into that specific initial approach allows you to think of, okay, well, the best way to get the latent state of most variables is an autoencoder. There are other ones, but autoencoders seem to work very well, and there's a lot of research going on how to do it well. And embeddings in itself kind of became like a discipline in the past 2 years, where now you can just Google embedding for text, and then you will find like literally every month someone has like a benchmark of how their embeddings do better with other ones. So you can leverage on all of this expertise that people are building like after their PhDs, like years of research. You can just really take that in one afternoon and just plug it in. So by taking that as one of the building blocks, we essentially enabled ourselves to not have to shoot ourselves in the toe every time we had a new data type and just kind of have to glue this thing together all the time. So that really made it easy because we're just leveraging on work that a lot of people have done, and we're enabling that work to a lot of people in a simpler way. Now, as you pointed out, mixing this information together, it's an art. But also that building block, as you call the first one autoencoders, the other one, as you put it together, mixing, is a mixer. And then you can experiment a lot. So since you already have vectors, and most machine learning problems can be solved once you have your data as a vector, then you can just try everything. So initially we were just throwing spaghetti at a wall, and we realized that for many of the problems, like XGBoost and this would work for like depending on your dimensionality of data. But then neural networks were just kind of like this tool that you can just throw any vector and predict any other vector, again the encoded state, and they will figure something out. And then the problem was, how do you pick the right neural network? And that's something that in itself is an art. But what we understood there is, if we pick neural networks for this, and again, today you can swap mixers as you wish as well. You can decide that your mixer is going to be an XGBoost or whatever mixer you have in mind, so long your data again is in vectors, which we guarantee. Then when there's a vector representation of your data, then we decided to focus on neural networks because for us, it was kind of like this Swiss Army knife that you could plug into data that you don't know what data is. You're just kind of like predicting from an input to an output. The challenge there was to extract information that we needed to extract to explain to people what's going on. And we made some innovations around the way that neural networks behave that are very simple, but nonetheless very powerful. The very first one is that we decided one of the biggest challenges was to understand how certain is this neural network about having found a problem and a solution to the problem. And you can do this if you make a really simple hack, which is you turn your weights into distributions. And if you train it like that, if the variances and all the weights gets really small, that's essentially telling you that this neural network is becoming more and more certain having found it. And if the variances are very high, it means that essentially with the data you have, still there's not enough information or at least because the neural network is not good enough, or because the data that you have doesn't have enough information to get to an answer. The other innovation that we did was, and again, a lot of this we don't invent, we just kind of bring them in, plug into the approach. But this one in particular kind of is bewildering to us because people don't do it, and it should be very easy to do. And it's when you train a neural network, you usually train this neural network to predict just the target variable. But at the time of training, you also understand what the error is. So you, in theory, could make this neural networks learn not just the output, but a measurement of error. So we call them self-aware, but essentially it's just adding another target variable where they predict the variable that they're trying to predict, and they also give you an estimate of how off they are. And on training time, since you know this variable, then you essentially can backpropagate it. And you're making these neural networks aware of how good they are at predicting given the specific input that you're given. And this in itself, the combination of two, can allow us to probe these neural networks to extract meaningful data for explainability sense. And that's essentially what our mixers do today. So most of them are neural networks, but they're just modified in the sense that they enable us to extract information for explainability sake.
Nice. And so it's sitting there, it's figuring out its learning rates, it's kind of getting there and mixing everything together, and that's creating a history of how it came up with that answer for explainability.
Correct.
Great.
And diving more into explainability, if you have time, I think that one of the other things that we've discovered is humans, we don't have the capacity to remember everything that we see and everything that we kind of learn from. And therefore, a lot of the building blocks around explainability have been built around the assumption that it has to work like humans. But in reality, machines don't have any problem with kind of like keeping the data that it learned from. And therefore, it has like this very precise memory of its learnings. And I think that the next innovation that we're doing in terms of explainability is that when you have a prediction, it's really easy for you to find what were the examples that are very similar to this prediction. And that in itself is usually what when you ask a doctor, like, hey, I think you have cancer, and you ask why, it would be like, well, you have this pattern. And again, if you really keep asking why, it's going to tell you, well, there's a study that says that 20 people like you have cancer. So by being aware that machines don't have that constraint of bad memory, then we can just use that. And it's important to keep that in mind. So a lot of the things that we're trying to do right now is how do we bring it back to what is the simplest way to give an explanation to a domain expert without having to think of these things have to be brains or they have to be exactly how.
Very cool.
Yeah.
Very.
So I have another question here. We are getting toward the end of our time, but I do want to ask this. And this is, so if I have a data store, let's say I've been gathering data, I have some analytics, or I have, maybe I'm just going to pull stuff out of one database and feed it into the system. Is this something that I would just feed the data into in parallel as I go, or run off to the side? Or is this something that I would just spin up periodically and go, okay, I want to know this, here's the data? I mean, what's the approach there?
That's a great question, Charles. So initially, we made it as this Python library, and therefore you have to kind of like build everything around it, like all that infrastructure, keeping versions and retraining the data as you see fit. Now, as we start to get feedback, we realized that, a seamless integration to where the data is probably the best way to cut a lot of the time into from idea to trying it out. And actually, we're already working with some database libraries, especially because our investor, they were like the founders of MariaDB, and they understand that there is this kind of need for machine learning to be embedded into databases. So the way that we're shipping MindsDB 2.0 is that it comes already kind of ready for your databases. So essentially, you can enhance your database capabilities. Mm-hmm. We're starting with most of the open source databases, but essentially such that you can train and you can see models as tables. So if you want to predict cancer and you have a cancer model, you can say, okay, select from the cancer model where, and then you can just pass the conditions. And you can join it as well with a table where you have information about the patients and that. So the ability to deal with machine learning straight from the database, regardless of what your database is the approach that we've taken in what we call MindsDB 2.0 to ensure that the cycles that you have to go through are shorter and shorter to apply machine. And the first one that we wanted to shrink in MindsDB 1.0 was the model generation, testing, and training. In MindsDB 2.0, we support all of that, but we keep it as close to the data as possible. And again, since we are open source, we don't have any restrictions. So if you're moving data to a third-party cloud, you can just run this on premise, and that enabled us to really make it so that you can just plug to your database wherever it is. You just install a MindsDB server side to side, plug it into your existing database, and then by default, that are extending the capabilities of your database to do machine learning.
That is cool. And does it hook in, because you're talking about integration, so does it hook into things like change hooks and things like that in that database, so that it just, you can set up a hook in MariaDB or PostgreSQL or MS SQL, and then it just says, okay, I got this, and I know that when I get this kind of a change, I need to write it out to MindsDB. Is that kind of what you're looking at then? Or are you looking at more the sort of, okay, go pull in any new data periodically and do the pulling method?
That's the right intuition. The first one, Charles, I think that we understand that people have already built infrastructure on existing databases to do hooks. And even if your database doesn't support hooks in your business logic, you do them. So, and you do them through the database anyway. So we wanted to not reinvent the wheel there. And we just wanted to empower people to use the tools that they already use and essentially be able to plug this workflows seamlessly and see predictions as data that exists, even though it's just a prediction. And the best way for us was to have this seamless integration with the database that they can do and leverage on the existing capabilities that they have.
Now, what if I'm using some kind of third-party analytics engine? Do I just export that data as a spreadsheet or a CSV and then just import it?
Yeah, the answer for that is twofold. Like, if you're not using a database, then again, you can connect to MindsDB through. So essentially, anything that you build in MindsDB Python library, you can save, and then you can load into what we call MindsDB Store, and that allows you to expose your model through a normal RESTful API, and you can just query it through.
Okay. So I would have to write some code that would grind through that data and submit it through the REST API.
Correct. Unless, again, it's already, and the second part of the question is, or the answer is, if it's already plugged into your database, then you just make a query to your database, which most BI tools that you use today already plug to most databases. So by looking at models like tables, then essentially do the same thing through the BI. You just run a query. This query is going through your database, mixing the data in your database, running it through the model, and returning as if it was a table that exists.
Makes sense.
Yeah.
You have any other questions, Gant?
No. Now I have, my weekend got ruined because now I have to download this. Thanks a lot, Jorge. Now I have to go ahead and look at MindsDB all weekend.
Yeah, please do.
Gant's significant other is going to be like, what are you doing?
Well, that she constantly says that, by the way. She's so yeah, back when I was making Nicolas Cage identifiers for web and phone, going through that data and deleting photos. She walked behind me. And from that moment ever, she doesn't think I do any work.
That sounds like my mom, right? I own my own company and therefore I don't have a real job. Can you come fix my house?
Work
you don't
from
have a
home,
real job.
No one hears the work part. They just hear from home. So, yeah.
You're just hanging out and playing Zelda all day.
Oh,
all right.
I wish.
Yeah.
There's a saying in Colombian, I don't know how to properly translate it, but it's find your obsession, make it your profession, and you don't have to work a day in your life. Something like this.
Nice.
So you guys are living it. So there you go.
Yes, indeed.
Yeah, I think there's a similar saying in English. So, all right, Jorge, if people want to check, I had another question and I've been sitting on this the whole time. So I'm going to ask it and then we'll go. And that is, so you keep talking about co-founder, MindsDB being open source. And what I find is MariaDB is kind of the same thing, right? You know, they have a commercial arm and an open source arm. I'm curious, so what is the business model for MindsDB, right? If people get into this, you know, how do you make their life easier if they have money to give you?
Yeah, so that is one of the advantages of having an investor that, you know, has walked the path that we want to walk. They understand that the objective is to kind of provide value through a tool that anyone can get. And then there is this balance that is not that hard if you do it right, of understanding what are the needs for bigger players that could help you, you know, make this a viable business. And what we understand here is we're building this so that 90% or 90% of people don't have to pay for MindsDB. And then we have some features that are only relevant to players that are managing data at scales that most people don't. And therefore, MindsDB enterprise focus is in terms of scalability. And we're talking of data sets beyond the terabytes and that. So that in essence is allowing us to empower as many developers as possible to do machine learning without really having a commercial interest behind them rather than just providing value. And then on the other hand, the value that they provide for us is that they're helping us test and prove MindsDB works at scale, all kinds of scales, all kinds of problems. So it's a very symbiotic relationship like most open source ones are. And then on the other hand, we've been approached by players that have needs that are not common, very rare within the normal use cases of open source. And those are the ones that we focus on for the enterprise.
Cool. All right. How do people find you on the internet if they want to talk to you or find out more about MindsDB?
Yeah, Jorge at MindsDB.com, or if you want to reach the founders, it's management at MindsDB.com, and github.com/MindsDB. You'll find us.
Awesome. All right. Well, let's do some picks. Gant, do you have some picks?
Yeah, well, I'll say that I've got some pretty cool inventions, but I don't know exactly when this episode's going to drop, so it might be afterward. So definitely check out some stuff. I plan on building a website for public speaking that allows people to open up their phone apps and point or their webcams and point the camera at their faces. And as the audience smiles or gets sad or something like that, all that data goes to an Amplify app sync server so that you can see how your audience is feeling. This is the most robotic. Nice. This is the most robotic way to read your audience ever, in case you're a nerd and you don't want to make eye contact. So I think that I'm going to have that at enjoyingthe.show and plan on making it so that if you have a virtual conference or something, you'll be able to just give everybody the link, and then you'll actually see a graph of whether or not people are laughing and enjoying, and it'll use facial sentiment analysis. So that's my goal. It's not written now while we're recording this, but I think it'll be ready by the time this drops. So pretty fun little project, and that'll be my pick for today.
Nice. Yeah, that sounds really great. Especially, I get the feedback on my virtual conferences. It's like, well, I can't see the audience. And I'm like,
right.
Yeah, I kind of encourage them to, emote in the chat, but it's hard to remember to do that. So
yeah, this will be an interesting thing, especially with the virtual world that we're in. You'll essentially get a pie chart of how well everyone's how well you're doing during your talk. Yeah. Although everybody's just going to enjoy themselves and start making angry faces. So I don't think it's believable information. We always we operate differently once we're observed, don't we? So We'll see.
Yeah, absolutely. I'm going to throw in some picks. Now, this is more on the marketing side of things. I've really been getting into marketing funnels. I've been doing conferences. Nice. I'm looking at finding new ways to bring in sponsors, and also marketing funnels will help the sponsors. So I'm also looking at adding marketing funnels to the sponsorship offerings for some of the sponsors. And anyway, so nice. It's been kind of interesting on that front to dive into. I've been basically consuming everything that I can find by Russell Brunson, who founded ClickFunnels. So I'm still new to ClickFunnels. I'm not going to throw out a pick endorsement on it, but you can go check it out. I am going to, however, pick his books. There are 3 of them. There's .com Secrets that he wrote first, then Expert Secrets, and then Traffic Secrets is the brand new one that just came out. And then I'm going to also throw on a pick. I've been doing the One Funnel Away Challenge. Now we're in like the pre-training week. So it's been, look, you've got to believe this will work. And here's kind of the setup that you have to understand in order to actually start building funnels. So I'll start building funnels. I'm already playing with ClickFunnels, so I'm already building funnels, but because I can't help myself, that's why I became a coder. It's like, oh, that looks cool. I'm going to go play with it. But yeah, so I'm going to throw that out as well. And then I also just want to let people know that we are doing more remote conferences. Gant is going to be speaking at the React Native Remote Conference at the end of July. Hopefully the show's launched by then. We're still working out some of the details there. And then I also have iOS, React, Rails, Vue, and Angular planned. I'm looking at doing DevOps and Agile, so hang in there for those. I'd love to do a machine learning one, but I think I need to meet more machine learning people before I can really get that rolling. I don't know. Maybe I could just reach out to everybody I can find that has machine learning in their LinkedIn profile. But anyway, that's where we're at. So that's what I'm going to shout out about. Jorge, do you have some picks, some things you want to just let people know that are awesome? Doesn't have to be tech. It can be anything.
I've been reading these books from Ian and Banks. Awesome. If you're into science fiction, this guy is it's really amazing. On the other hand, there's this, I'm actually calling it from my phone because I ran out of credits on this, but it is Crisp. Essentially, they use AI to remove noise. And man, I usually don't pay for plugins to your laptop, if you may, but I do miss having missed out of my 120 minutes that they give you for free because it really makes a difference. And I don't know what laptop do you use, but Mac, when you're speaking on the native microphone, it sounds like you have a turbine next to you. And Crisp just removes that. And anyway, I think that's a fine, beautiful little gadget that I liked, and I think I'm actually going to pay for it.
Of course, you'd choose an AI pick that helps you talk to people. That's awesome. Yeah, Crisp. I have to +1 on Crisp. It's fantastic. Yes. By the way, there's a new competitor I'm not sure you're familiar with. NVIDIA, if you have an NVIDIA graphics card, NVIDIA RTX has a new thing where they're for free, I believe, because they just want you to buy NVIDIA products, have a noise cancellation. So if you do have a NVIDIA graphics card, you might want to go ahead and put that up against Crisp. The reviews seem amazing. I'm not sure which one's better. That would be a really impressive blog post by some. I don't know, even the experiments you'd have to go through for that would make you look crazy. But yeah, I love Crisp. And then now that NVIDIA's got this thing, got to pick one of them.
Well, I'll definitely try it out. Thank you for sharing it, Grant.
Awesome. Well, we'll go ahead and wrap this up. Thanks again for coming, Jorge. This was fun.
Of course. Thank you for inviting me as well as sharing your wisdom.
All right. Well, we'll go ahead and wrap this up. Until next time, folks, Max out.
Thank you, guys. Thank you, Charles.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.